grip of these two materials, yesterday and today. Okay, because this is the foundation. If you just don't get it, the definition, conversion from exponent to logarithm, you will get lost, especially in the properties. Okay, so let's start not starting by the properties. Let's just go to the definition first. So yeah, this is what I'm doing. So I will save time to upload if you need the video, and yeah, okay. So let's get back to the material. There are three main things that I want to discuss. Actually, it is from your textbook, three examples. So the first one, the position. So whenever I have 10 to the power of A equals C, so A equals log C, right? So if I'm saying that 10 to the power of 2 equals 100, it means that 2 will be equal to log of 100. Sorry, yeah. So the exponent equals to log 100. And I want you to see this way, okay? If I'm speaking about what is log 32, okay? If I translate this, I want to ask you 10 to the power of what? So it becomes 32, right? So when I'm asking you, what is log 523? It means I'm asking you 10 to the power of what? So it becomes 523. That is the translation. Okay. Therefore, if I have log of 10 to the fifth power, it means 10 to the power of what? So it becomes 10 to the fifth power. Who can answer me that?
5.
5. Good. Therefore, log 10 to the fifth power, it will be 5. Because the question is 10 to the power of what? So it becomes 10 to the fifth power. Therefore, if I'm asking you log 10 of half to the half power, okay, I'm sorry with the language, it must be half. If I'm asking you what is log 10 to the power of -3, it must be -3. So just take the exponent here. And don't forget that the exponent here, the base is only 10, not log 10. Okay, so -3 is the exponent of 10. Okay, I want you to keep in mind here. There will be a big difference. So for example, log 5 square, it is equals to log 25, right? But log 5 square, it's just log 5 square, because the one that being squared is log 5, log of 5. Usually we use this one. Usually, that is the way of, so it can be the left technique, it can be the right one. Okay, so don't forget, whenever you have a power, an exponent, you have to be clear the base is the 5 here or the entire logarithm. Okay, since it makes a big difference. So what I'm speaking here, the previous example, the exponent must belong to 10. Okay, whenever it belongs to 10, there you can just extract the exponent. So let me just give you an example. Log 10 to the power of 1000. Don't forget that 1000 is the exponent of 10. Therefore, you can be certain it will be 1000 itself. Okay, up until now, any question? So for the first one, I want you to be clear with the form. You change the exponent, and to the logarithm. I want you to have the ability to translate the problem. What does log of 32 means? Log of 32 means you want to find 10 to the power of what, so it becomes 32. That is the concept. Okay, and the last one is based on that definition, you can conclude that if you have a problem of log of 10 to the what power, any power, a, we can negative, it can be fraction, it will be a itself. Okay, this is the conclusion, the third one. Okay, any questions so far? This is
Yes,
from
sir.
the, yeah,
So for the parenthesis log 5 squared thing, we
yeah,
cannot
this
like
one.
distribute the square because log 5 is one thing.
Good, good, yes. You cannot do that. Log 5 is a one thing, one number. You cannot distribute log square, 5 square. No, because log doesn't stand alone. It needs a statement, which is 5. Later I will describe about what is statement. Yeah, but that is a good question and clarification, because log 5 is standing as one unit. Any other question? No, we're good. Okay, good. So now let's go to number 2. We are still speaking base. So I want to postpone. I think I need time. So tomorrow, the video will be when the base is not 10. So we are not coming to the properties first. I'm not comfortable to leave you with the properties this quick. So let me just still dealing with 10 here, yeah, as the base. So let me go to the second one. So the second one, if I have 10 to the power of 7 equals to, wait, 10 to the power of, wait, no, 5 equals x, it means you can do something on the left as long as you do the same thing on the right, right? That is the equality axiom. When I multiply the left with some numbers, I will multiply the same numbers to the right. So when I try to put log on the left, it means I need to do the same to the right. That is the second thing. Okay, so if A equals B, then log A must be equal to log B. Yeah, this is just the equality axioms of logarithm. Okay, what is the application? The application is we want to see the consistency of these two big things, the first things that we have learned. Okay, so let's see the consistency here. So previously we know that log 10 of 5, okay, equals 5, right? So if I pretend I don't know that, let's go back. If 10 to the power of 5 equals x, and wait, log 10 of 5 will be log x. So 5 will be x. I'm just showing the consistency here. Okay. For example, if let me just put this in my pocket. Okay. But since I know that, wait, if there is a question, 10 to the fifth power equals x, and then you put log on both sides. Log 10 of 5 must be equal to log of x. right? And we know that log 10 to the fifth power will be equals to 5, right? Therefore, 5 equals to log x. See the consistency? If I want to translate this directly to logarithm, 10 to the power of 5 equals x. It means 5 equals log of x. So this, I use the first definition. But this one, I use the second rules when I put log on both sides. And they both consistently showing the same result. Okay, that is when the axioms is accepted, when they are consistent to each other. Okay, they are proving each other and they are not conflicting. Therefore, whenever you have like yesterday exponential, I give you problems and then somehow you think that you did it right, but you have different answer, there must be something wrong because there is a consistency in the axioms and the result, the final answer must be the same. Okay, so yeah, for this part, do we have question? No, we don't have question. So let me go to example from the textbook if we are trying to discuss number 2. So the textbook provide us 10 to the power of x equals 457. And how can we use this second thing when I put log to both sides? How does it work? So when I put both sides log, so logarithm of 10x, 10 to the power of x, equals to logarithm of 457. And we know that log 10 of to the power of x will eventually equals to x, right? The definition before. So x will be equal to log 457, which is yes, which is true. If this is the case, we can directly define it or transform it into logarithm definition. Okay, so I'm just showing you proof of the consistency, not just to confuse you that Mr. is just the same. I know it's the same. That's why I prove it. That's why I want to show the proof it's the same. But in the end, of course, I expect you to train yourself directly from the exponent form. You can translate it into logarithm form. Okay, you can choose either using the second definition or second method. You put log into both sides, or the first definition that we have already uh, discussed previously. Any question up until now? No? Okay, the last one. Okay, so this is actually all the material for the first part of your homework, right? The first part only, because the second homework will be, I think, is here. The first part, and the third one, let me just use the example from the textbook. This is what case question yesterday. Mister, how if I have the base is not 10, 5 to the x power equals to, for example, 255. Okay. Now, I don't want to explain you about how the log works with different base. Let's just pretend that we only know 10 as its base. Okay. So because we only know 10 as its base, we have to enforce it to convert 5. We convert 5 if 5 equals to 10 to the power of k. Okay. I hope you know the objective. The objective is we want to solve this, but I just know about how the logarithm with 10 base works. So I don't know how about logarithm with 5 as its base work. Therefore, to solve this one, let's forcefully convert 5, the base, into 10 as the base. But of course, to make it so the question is, you cannot just convert 5 into 10, right? Because 5 and 10 is different. So you cannot just convert 10 to the power of x equals 255. No, of course, you cannot do that. You are changing the question. But the thing is, if I put into 10 to the power of k, of course it can be acceptable because the k can be a certain number that makes 10 to the k power equals 5. But we don't know what is the k. Up until now, any question? So I want to forcefully put 10 as its base. Okay, so because I have this definition, I just replace 5 by 10 to the k power. So 10 to the power of k to the power of x equals to 255. So 10 to the power of kx will be equals to 255. Therefore, let's just use logarithm both sides. Logarithm 10 of kx equals to logarithm 255. Therefore, kx equals to logarithm 255. So x equals to logarithm 255 over k. Now, Mr. We still haven't found the x, right? Or what is k? Because I just only know I just don't know what is k, what is x. To find x, I have to know what is k, right? K back. Let's go back to the first definition. If 5 equals to 10 to the k power, okay, let me ask Flavia, can we know what is k? 10 to the k power equals 5.
Log
Then,
5.
good, k is log 5. Therefore, I know that x will be equal to 255, log 255, divided by log 5. And use your calculator, then you will find the x. Okay, I want you to master this skill. Why? I know in the end, some of you have this condition, learning habit. Oh, yang penting akhirnya, ya. Jadi nggak perlu. Mister ingetin, I really intentionally teach you all of this because the properties later will refer to this approach. So I want you to understand how we come up with this. Because let me just show you one more example. 6 to the power of x equals to, for example, 1,000 to 1,200. Okay, let me show you how if we force it into 10 as its base. So I will make a statement that 6 equals to 10 to the k power, right? So I will replace 6 by 10 to the k power to the x power equals to 1,200. So 10 kx will be equals to 1,200. So kx, let me just go directly, equals to log 1,200, right? Therefore, x equals log 1,200 divided by k. And I don't know what k is, but I can find the definition of k from here because k will be equal to log 6 since 6 equals 10 to the k power. Therefore, log 1,200 divided by log 6. Can you see how it works? This is 255. This is 5. 255. This is 5. This is 1,200. 6. 1,200. 6. So actually, we have created a new property based on the definition. The conclusion is, but I want you to, this is on the textbook, and I want you to understand, and I want you to really follow these steps because this will be imminent for the properties. But the conclusion is simple. Yes, the conclusion is simple. Whenever I have 6 to the x power equals to like 1 to 5, then x will be equal to log 125 divided by log 6. Okay, so yeah, that is the last thing that I want to teach you. So I want you to follow. So everything that I have explained is written on the textbook, and I want you to take it on to your notes. But again, I want you to follow the instruction on the textbook whenever you do the homework. So for the homework on the first part, you can use the calculator, since of course you obviously cannot do it mentally. But for problem number 2, I think it's simple. But problem for the second section of the first part, like 3 to the power of x, I want you to train yourself. Okay, let me just show you the problem. So number 14, 3 to the power of x equals 2. Again, homework is for you to practice. I want you to try at least once or twice. Don't use directly this. Because yeah, that's the properties, but you have to know where it comes. So I want you to practice yourself. Use the analogy. If 3 equals to 10 to the power of k, so 10 to the power of k to the power of x equals to 2. In the end, 10 to the power of kx equals to 2. Therefore, kx equals to log 2. And x equals to log 2 divided by k. What is k? From here, k equals to log 3, right? So because when you do it step by step, you are training yourself to the definition. The main thing about logarithm, I keep reminding, is the definition. How do you convert from the exponent into logarithm? That is the most important thing. When you lost this, the properties gak usah belajar, pasti hancur. Ya karena kalian nggak dapat gripnya itu. Oke, dibolak-balik aja. Definitions of log, definition of exponent. Okay, so yeah, any question? Especially for those who have already started the homework, I believe maybe you still have struggles. And the second part, I want you to understand the second part, you cannot use your calculator. The second part, for example, we have problems like log 3 of x equals to 3. Tomorrow I will give you the video, but if you can read it and understand it, just move on. So in the end, you know that 3 to the power of 3 equals to x. So x equals to 9. So always convert this into the statement of exponent to solve it. It will be simple, but it will train you to convert from logarithm to exponent. Previously, the first part, you are practicing yourself to convert from exponent to logarithm. You get the point here, okay? So the first two parts, you are practicing converting logarithm to exponent, exponent to logarithm. Okay, so any question? Very good. Okay, so if there is no question, I hope that you can use tomorrow to really strengthen the definition. Next week on Monday, we are starting with the properties. Okay, again, you cannot handle properties when you are not strong enough in the definition. So do your part as best as you can. Okay, you can be dismissed.
Thank you, Mr.
Thank you.
Welcome.
Thank you, Mr.
Thank you, Mr.
Thank you, Mr.
Thank you, Mr.
Welcome.
Mister.